So, good morning, everybody. Welcome you all. A warm welcoming from my side, Suvankar from Fisher. So, today we are going to discuss about special solution for fixings on corners and curved surface. I want to thank you personally for joining us. I want to introduce myself. I am Suvankar, working as field engineer in UAE. My user ID is Fisher MEA, and I welcome my colleague, Mr. Naveen Shanmugavel. He is Deputy Marketing Manager. His user ID will be Fisher Support. So if you are having any questions or any queries or any lagging in the video regarding the online, you can directly ask us in chat box and we will be answering you or solving the problem. Our time speed today is for the webinar, it's 45 minutes from 11 o'clock to 11:45. And question answer session will be there for 10 minutes, 11:45 to 11:55. And there will be poll and feedback session for 5 minutes from 11:55 to 12 o'clock. I will request you, like, you please attend the poll and feedback session. Give us the feedback. How was the seminar? What you learned, or where we can improve ourselves for our future development and serve you better. For your better experience, use only Google Chrome, because Google Chrome and Firefox, from our past experience, we saw it's giving the better video streaming. Please do not use any Internet Explorer. Internet Explorer, there is some errors coming for the live streaming, and also there is sometimes some lags. Please do not do parallel downloads, which may lag your connection. Questions will be answered at the end, so we can keep our flow. All the questions will be answered at the end, or we will come back by mail or personally visit. Gifts for some correct answers. So there will be questions in between the presentation. So be aware, give us answer. Who will be answering first, he will get the gift from Fisher. This is a basic screen sharing, how it looks like on your screen. If you see, there is a expanding button. If you click this, you will able to see the video in full screen mode. If you are, there is chat tab. If you are having any problem, any query regarding the online issue, you can make us chat here. We will be answering you. There is question tab. You can put your questions over there, which will be answered at the last. And there is polls tab also, which I will again personally request you for our development. Please polls us how the webinar was informative to you. So now, again, our today's topic is special solution for fixing on corner and curved surface. So the challenges, how we are finding the challenges in the market, or like in the current projects, ongoing projects, or which is already done. Basically, the challenges is coming for circular column. There is so many times you will find circular column. We will be discussing on it, why circular column, and how you are going to do the design calculation for circular column, the anchor connection, how it will looks like, which is the much more conservative way to approach, and how we can find the solution. So let's begin. Circular column is there is different reason for circular column. There is structural reason. It is because of structural strength circular column people are using in the structure, and as well as architectural reason. So most of the time you will find, maybe in some parkings area, you will find circular column or oval column. Both are in terms of same almost. You will find in the lobby area of big buildings, you will find the circular columns. So basically, you see, this is a parking area in UAE. I found a circular column, or like it looks like an oval column. And if you have to fix a beam on the face of the oval, how the calculation will be, because our calculation is always for the flat surface. So that's our biggest challenge. But before I start that, I just want to ask you, what is the type of anchor failure happening under tension? What do you think, guys? What is the types of anchor failure happening under tension. So let's see. Under tension, failures is like, it can be steel failure when your load is high and your steel diameter or like anchor diameter is very less, then the steel will get failed. There is anchor pull-off failure. Basically, anchor pull-off failure is happening because of high load, incorrect installation most of the time, and if there is less bonding strength of the chemical to the anchor, chemical to the concrete. So there is another failure, which is concrete cone failure. Even if our anchor is strong, our steel diameter is big, if your concrete strength is very less, then the concrete cone failure is happening. Basically, the anchor is coming out with a part of concrete. And there is splitting failure for the thinner member. If you are using very thin member and you are using the anchors over there, when there is the load is coming, the member itself getting splitted. Now, what is the failure type for shear? This is very basic thing. We are going to discuss more deep about it, how we can find the solution for these problems. So let's little bit discuss about it. There is steel failure again. If the diameter is smaller than the required diameter, or then the steel is failing. Concrete pry out failure. It's basically in the formula or in the theory, it's mentioned like it's based on anchor pull out failure under tension, or the pull out capacity. It's depend the pry out capacity. So again, if the anchor is pull out failure happening, the pry out failure, most of the chance it's there to fail. And concrete edge failure. Concrete edge failure is happening because of if it is very near to the edge, anchor is very near to the edge for the corner fixing. You know, if it is there, then concrete edge failure happening. So how we can avoid it and how we can get the better solution, we will discuss regarding it in our future slide. So what is concrete cone failure? We know how anchor works. It's basically embedded inside the concrete and then bolted from the top. You know which is embedded inside the concrete. It's called effective embedment depth, which is in terms it's HEF, means H effective, or embedment depth, effective embedment depth. So when there is a tension, the concrete is weak but the anchor is very strong, then the concrete is getting failed and it's coming out. So what is the dimension of this concrete, how it's getting failed? So you see, this is a real picture of a concrete cone failure, how it looks like. So basically, this is the embedment depth from the surface of the concrete till the end of the anchor. It's effective embedment depth. And then concrete surface, which is making the cone, or you can say the cone surface, it's 3 times of embedment depth. So if you are having embedment depth of 100 mm, you will have the diameter of the cone as 300 mm. This is the theory, or like the formula for the concrete cone failure. You see, this is a constant value for cracked and non-cracked concrete, K1. This is FCK, is the compressive strength of the concrete, and its embedment depth, HEF to the power 1.5. So basically, the concrete cone failure is depending on the strength of the concrete and embedment depth. What is characteristic spacing and edge distance? So to get 100% capacity of anchor in terms of concrete cone failure, you should keep the distance between two anchor as 3 times H effective, or 3 times of embedment depth. Then you will get the 100% capacity of each anchor. If it is lesser, in the actual case it's not possible, because when you are having embedment depth of, let's say, 100 mm, you are having spacing of 450 mm in the actual site, actual case, it's sometimes not possible. So as near it's coming, the reduction factor start working for the spacings. There is edge failure, which is 1.5 times of H effective. You can see here in the picture. So this is the cone. So half of the cone, it's 1.5 times H effective. If the anchor is from the edge 1.5 times H effective far, then there will be no influence from the edge will come again, which is sometime not possible to keep in the site. So let's see how we can make it possible and what will be the solution for it. Before that, I also want to talk what is the anchor capacity influencer here. These are the anchor capacity influencer, where the anchor, even if it is the strongest one, but if your member is width is very small, then the anchor capacity reducing. Member thickness, it's governing the splitting failure, so anchor capacity again it's influencing. Spacing between anchor, we already discussed how the spacing is influencing the anchor capacity. And edge distances, much more critical. If there is very near edge distance is very small and you are having a shear load, so there will be the edge failure, chance of edge failure. And anchorage depth is also playing a vital role in terms of edge failure, pry-out failure, concrete cone failure, all of this. So let's going towards the case study. Fixing steel beam on curve column. It's either can be steel beams, it can be any kind of base plate you are fixing on curve column, but how the approach should be, how it will be solved, and what is there. Basically, there was a parking area in UAE. There was a parking area which project I work. There was parking in first floor and there is parking as like second floor. But as this is a busiest mall, so you know the parking started, people started coming more, so it got busiest one. So they want to introduce a intermediate slab in between. So there will be some I-beam going connected to from one column to another column, and then there is a slab intermediate. So this slab also can be used as a parking lot. Now, when we approached them and found the shear load for this one beam connection to the column, it's coming 675 kilonewton, which is 67.5 ton. It's a huge force, right, guys? Now, when we try to approach also for a solution, we found there is no standard design procedure on the curved surface. How we will do the design calculation? Always design calculation as a standard, it's flat surface. So we came up with some engineering judgment and some solution. What is that? So our first proposal, first solution was, this is a circular column. Now, this is the cross section where you can see the anchor in green color. Let's say it's 85 mm embedded, and from one anchor end to another anchor end, it's 90 mm. And you can see it's a concentric anchor, because on the curve column, if you have to keep this one perpendicular, I mean anchor perpendicular to the surface, it's always concentric towards the center of the column. So it can be circular, it can be oval also. Oval is also part of the circle. So I am talking about basically the curved surface, how we'll do this. So here you can see the concrete cone, it's forming, and concrete cone is getting making a common area which is 3343.8 millimeter square with this particular dimension. Now we thought we will not go for that. We will go for some more conservative method, which will be more conservative and there will be no failure happens. So to make sure that, we consider a small square which is inside the circular column, and we consider there will be a straight anchor design. In actual case, the anchor will be concentric, but in design method, to make it more conservative, we kept as spacing 90 mm on the flat surface, and I took the square column because the square column is having limited edge, as well as square column is giving the more common area for the cone. As you see here, the common area for two cone is much more compared to here, and this is, I found its common area is 4537.5 millimeter square, which is almost 1.4 times, 1.5 times near about. So for the solution one, why we went with square concept? Because there is limited edge. where for the circular surface there is no limited edge, it's basically a continuous surface. So there is limited edge in the square column, and there is the design is much more conservative. But we face a problem. You remember there was a huge shear force, 675 kilonewton. When there is 675 kilonewton of shear force, what will happen? It will break the edge. The edge failure will happen. And this is a column which is really high strength column for a big building, and this is consists of so many reinforcement. So how we can approach much more real way? We started thinking about it, and we found a solution which can be something like this. What is this? Okay, this is real case scenario. Actually, we did a finite element design for the base plate with the node mentioning as the anchor. Now, when we put the load on the finite element design for the base plate, and we found some load is coming on the anchor. This anchor load, how we took this anchor, every anchor load, and did the design for single anchor. Why I did the design for single anchor? Guys, you remember what I talk about, like if the cone is not making the common area for failure, then you can took the one anchor capacity as 100%. So basically from one anchor here till another anchor here, I kept the distance as 3 times of H effective, which means there will be no common area for the cone making or like influencing each anchor capacity. So basically I went with solution something like this. So there is a base plate, and now you are going inside the, it's basically a trial and error method. You are going inside the concrete as 100 mm, and it's giving you certain load capacity. Based on that load capacity, we have to do the finite element design, keeping 300 mm spacing between anchor, and we have to check like is it exceeding the capacity, action load is exceeding the capacity or not. If it is exceeding capacity, we have to increase the embedment depth, maybe 120 mm, 150 mm, and then again cross check like with 150 mm, 450 mm spacing, is it exceeding the capacity or not. So based on this, we found the solution and we got approved over there, and it was, I mean, awesome landmark, milestone for us, and we found the solution finally, and consultant approved and contractor approved, and this is the best way to approach, I feel, for the curved surface, going embedment depth and keeping the spacing between two anchor as 3 times H effective. Our recommendation for this anchor is high performance anchor FH2, which is having shockproof, and it is shockproof approval, which is having better shear capacity because it is a sleeve anchor. If this anchor not works, there is Fischer Superbond FIS SB390S, which is hybrid mortar. It's basically can work for short-term temperature of 150 degrees centigrade. If there is any provision for temperature, you can go with this anchor. This is also fast curing. There is Fischer epoxy mortar. I want to suggest also, this is like best epoxy mortar till now in the market. It's taking much more load, and the capacity of this anchor is very high. It's approved for 120 years service life guarantee. So this chemical is slow curing chemical. If you are having much more embedment depth, then you can go with this chemical. And there is, last but not least, I'm just making the limitation of the anchors, which is the most superior or most advisable for this particular application, is Fischer high bond anchor. Fischer high bond anchor, it's a high strength anchor in terms of chemical, and it really requires less edge distance, less spacing if you are doing design for some other cases as well. Now, our second case study for the top edge of the slab fixing bracket. Why you are fixing bracket on top of the edge, top edge of the slab? For fixing handrails or guardrails, something like that. So basically, if you see, there is two type of fixing for handrails naturally happening. Either fascia mount, which is fixing on the face of the slab, and there is base mount, which is fixing on the top of the slab. So when there is high shear load or high tension load, sometimes structural designers are going with some solution looks like this. Agree? When you are going solution like this, the problem we are facing is this L-shaped base plate. This anchor is working both in tension and shear. This anchor is also working both tension and shear. How we are going to resolve this? This is a big challenge for high tension force or high shear force, as well as it's near to the edge of the concrete. How we will resolve this problem? Let's see. This is the tension and shear combination, which I talked just now. If there is vertical load, upward load as tension on the handrail, you are going to get tension on this anchor and shear on this anchor. So basically this anchor will be under tension because of this load, and this anchor will be in the same time will be in shear. So this edge is going to become more weaker in terms of making cone and edge failure. We will come in the analysis. And there is, when there is Fx working, there is tension in this anchor and shear in this anchor. So again, this edge is coming worse for in terms of Fx. Now, what is the solution? For this, the solution is something like this. You take case 1 as there is one base plate, no other base plate. Put 50% of your horizontal load and 50% of your tension load, and go for the utilization less than 100%. So this anchor is now working as like shear and tension both. In same time, the case 2, you have to check also the top plate will have 50% of shear and 50% of vertical upward tension load. So based on that, your utilization has to be less than 100%, and then there is a, you might find a solution. But this method is not really conservative. Why? Let's go for small analysis. This is 2 anchor. When there is this 2 anchor, when there is vertical upward force working, Fz, basically this is what happening in actual case. This anchor is under tension and this anchor under shear, which is really worse. What is happening? This tension anchor is making cone and this shear anchor making edge failure, where this concrete area is going in the common stress area. It's getting common stress area, means it's getting worse in this kind of case. Now when there is shear in the base plate, you will find shear on the top bolt 50% and 50% tension on the side face bolt. Again, the tension bolt is making the cone and the shear, which is the top bolt, is making the edge failure. Again, the common concrete area is coming. How can we avoid this? Or if you are not avoiding, you are going to face the problem. How we will make sure this concrete is not overstressed, which is not possible with 2 different design. So how can you avoid it? So the problem came. Now the solution number 2 came in the picture. Like we think about it, we come up with a small solution like which is acceptable by the contractor and consultant. Base plate will be having slotted hole, which will really help you to give zero shear to the parallel plate. How it is looks like. Let's come. When there is Fx working, the top plate is taking zero shear. Full tension is coming to the side plate. And when there is Fz working, the side plate is taking zero shear and full tension is coming to the top plate. Let's go for small analysis for it. When you are having Fz, that time you will have this slotted hole in the side face of the plate. Because of the slotted hole, it is not transferring any shear to the hole, to the anchor, sorry. And 100% tension is going to shear to the top face of the bolt. That time, this top face of the bolt is making only cone, or the only check has to be done for the tension for the top face of the plate. When there is horizontal load Fx, you will find this is the slotted hole on top as well, which is not allowing the shear to transfer to the bolt. So there is 100% tension is working on the side face of the bolt, where we can search for the solution and we will find it. It's automatically working based on the tension. So the slotted hole is going to make your life easy in terms of shear. There will be no shear working, so there will be only calculation for 100% tension on this bolt for the horizontal load and 100% tension for this bolt for the vertical load. So what Fischer recommend for this? Fischer recommend Fischer anchor bolt FAZ2, which is available with the dome nut also, which is good in looks. This is friction controlled anchor, so it's basically working based on friction principle. This is Fischer concrete screw FBS2 ultra cut, which is basically working based on mechanical interlock. It's cutting the concrete and going inside. So this anchor, it's really not giving any stress to the concrete to get installed. So you can have very less edge distance with this anchor FBS2 ultra cut, and it's having very good shear capacity as well as tension capacity. I will propose you injection mortar, which will allow you to go as much as possible inside the concrete or as less as possible, because this is variable. It is a injection mortar. So based on your load, you can decide to go with chemical anchor or mechanical anchor. Both option we do have. And as I told you, this anchor is having 120 years service life guarantee. And last but not least, Fischer high bond, also it's a very good anchor. In terms of chemical anchor, it can be installed very near to the edge, and the spacing also required less than any other chemical anchor. So if the load is very high, you can go with Fischer high bond FHB2. So guys, I also want to recommend you to use our design calculator, which is free of cost. You can get from the internet. You will get the link in the chat box, and you can download anytime, register it. You can ask anytime, free training session, we can arrange it, and it will be much more helpful for you, make your life easy for the anchor design, which is very user friendly software. So in this software, you can do all of that design. Only the approach has to be, from technical point of view, the approach has to be changed, and then from the normal anchor design software, we can do the anchor design. Just to tell you, the all solution which we talk about today, it's all based on Fischer experience, our trial and error method, and we found this is based on engineering judgment, the best way to find the solution. Now we will go for the question answer session. We will look for if there is any question answers from you there. So Giridharan, hi. You ask a question: anchoring in top edge of slab after providing the slot, what should be the minimum edge distance to be followed? So as to avoid the cone failure, I know it's 1.5 time H effective, but what if the geometry is limited? How to reduce the tension capacity based on the overlapping of cone? Wow. Giridharan, I just want to tell you, every anchor is having a minimum edge distance mentioned in the ETA approval, relevant ETA approval for the anchor. You can find anytime in our website. If you visit fischer.ae and go for the relevant product, you can find the ETA approval. You can get from there, as well as how the reduction of the tension capacity is happening for the cone failure. As you asked, cone failure tension capacity, there is a reduction factor. It's a gamma spacing. So it's again based on the ETA. In ETA approval, it's clearly mentioned how to get the gamma S. If you need much more support, please contact with us. I will be happy to give you the documents, and I will be happy to discuss regarding it. Thank you very much. What is the minimum and maximum area of overlapping cone? Okay. basically when there is I understood Vikrant that you are asking, like when I talk about two cone which is happening for circular column as well as the square column, there was some maximum area, minimum area, something overlapping, that I understood. So what is that you are asking? Basically when you are installing two anchor, the critical spacing required 3 times H effective. So when you are having the spacing lesser than that, then each cone is overlapping another one. That's what I mean to say. The area of cone or the portion of cone is overlapping each other. So in terms of the circular column, as your anchor is concentric way it's putting, so you are having lesser cone combination with each other than the square one. So square one is having much more conservative way, because square one we are considering the cone overlapping is much more than the circular one. I hope you got the answer. If you are having still a question, you can ask anytime, Vikrant. You can, we'll be in touch with you. Giridharan, another question I got, what if we don't have that 3 times H effective distance to move? How to design the single anchor if the cone surface is overlapping? I'm going through once again. What if we don't have the 3 times H effective distance to move? How to design the single anchor if the cone surface is overlapping? Okay, Giridharan, basically the overlapping, you don't have to do the single anchor calculation. There is another one calculation, then it will be there along with it. There is first you have to find out the capacity for single anchor, and then there will be the reduction factor, area of the one concrete cone divided by area of the area of the total concrete cone for two anchor divided by area of single concrete cone for the anchor, and then you will get the load capacity. I can share with you again the ETA approval for this particular area where the formula is mentioned. This is basically a simple formula. You can just multiply and get for two anchor what will be the capacity for concrete cone failure. It's easy, sir. Michael, I got a question from you. With the slotted method, the anchors escaping the shear force become redundant. They are not no use then, or do they play any role? Okay, Michael, I put slotted hole, so there will be no shear load. So when there will be only tension will be taken care by that slotted hole or the slotted hole to the anchor. So basically when you are providing the slotted hole, it's not transferring any shear to the anchor, and it's transferring full 100% shear to the other face of the anchor. So the anchor design only by tension you can easily find this anchor is suitable or not. If there is any load as a vertical load, then you have to do the tension check for the top bolt, and if you are having horizontal force as a shear force to the handle, then you have to check the again tension load for the side face bolt. Is it fine? I mean, you understood my conversion? If no, then Michael, please let us know. We will be in touch with you, and we will make sure that this is you understood the proper thing correctly. Athira, hi Athira. You ask a question. What is the minimum edge distance for bolt from PT slab? Athira, I want to tell you there is minimum edge distance for every bolt. It's not about PT slab or a RCC slab. Basically this is all about the concrete. So when the concrete you are installing a bolt in the concrete, so there is always mention the minimum edge distance in the ETA approval. You can easily follow it, or you can use the same design calculator Fixperience, where it's always telling you if you are going lesser than the edge distance required. It's giving you the red indication like this anchor cannot be used for this small edge. Any other question? So guys, I will also ask one. There is another one question which uh, which No, almost all question cover. Sorry. So I think it was a great session for us, and we hope you learned something. And looking forward to meet in our next session. Giridharan, you are the winner for the question answer session. You answer as this is the steel failure. I also want to mention, there is, as I told, there is some other failures as well in terms of tension. So thank you very much for your attention. Please go in the poll tab and please poll for us if how we can improve our webinar, and how you found it was helpful for you, it was informative and educative for you. It will really help in our next webinar for the presentation. From Iguin, there is a question: how about the moment reaction if that is balustrade bracket? Okay, Iguin, when there is a moment, again, anchor does not understand moment or torsion. Anchor only anchor design calculation only is based on either shear or tension. So if there is moment, we can transfer the moment towards tension or shear in the bolt, and then we can go for it, checking the same, like if there is any tension or if there is any shear, as we discussed. Giridharan, again another one small question from him: can we take top and face of slab as non-crack concrete? Giridharan, actually, this is based on the structural design of the project. It's only structural designer who did the design for the project can only suggest you. Basically, it's not always non-crack concrete, as you know, because for the cantilever beam or like cantilever slab, always top face is under tension. So top face of the slab is not always non-crack. So it's always better to discuss or take the suggestion from the consultant who is in the project, or the structural engineer who is taking care for that project. Just I want to remind you all, please use that poll tab on the right side of the window next to the question tab, to give your feedback of the webinar. We value your feedback. Actually, we value your feedback. Mr. Giridharan, our team will be in touch with you to provide the gift, and you will get your gift very soon. Congratulations, sir. Nice to see your answer in polls tab. I appreciate who took time to give us the feedback. It will really help us. Please, ladies and gentlemen, be with us and give us some feedback and your opinion, how we can improve our webinar, how it helps, is it really helps? Please. So we will wait for another 5 minutes for the polls, and before ending the webinar. So we will end our webinar by 11:45. Please give your poll before that. It will be really helpful for us. Again and again, I'm saying. And if you are having any question at any point of time, please contact us. Please be in touch with us. We will be happy to support you anytime, any point of time, and anywhere. Also, guys, if you are facing any problem in your project apart from this, where you found like there should be a solution, and how fischer approach, or there is so many things we can discuss over webinar, please give us the feedback, and like let us know your opinion, where we can also do a webinar to come up with a solution for your problem, and or which is like most of the time you are facing in current projects. So please let me know, or let us know the problems which you are facing, where you want webinar, in which topic you want, which will help us as well as you also to learn and grow together. Giridharan, I got another one question from you. Basically, nowadays everyone use limit state. I can, one moment. Uh, I cannot read afterwards. Limit state design to design RCC structure. If that is the case, then elements are cracked. So nowhere non-crack concrete shall be considered in the project, right? Okay. Non-crack concrete, it's basically like sometime if it is a big project, it's nowhere you found, but in the, think about the foundation area, or like temporary application at the beginning of the project, or if it is a temporary application for certain time or certain period of time, like shuttering, like handrails for, or like guardrail in the project, that things can be considered as non-crack concrete. Again, depend on your structural engineer and the consultant who is there in the project, based on their suggestion. um, Mubassir. Mubassir Ahmed. Hi, Mubassir. The spacing is applicable for hollow structure slab. Mubassir, actually, we did a seminar on hollow structure slab. Hollow structure slabs are hollow, which is called hollow core slab. Hollow core slab is fully different material in with normal solid slab. So basically, for hollow core slab, yes, we can come back to you. There is different anchor, and the spacing theory is not applicable for hollow core slab, sir. I just want to mention here, in hollow core slab, the anchor is basically working based on the undercut method. So the anchor is going inside the hollow portion and getting locked. So this method is fully different compared to the solid structure. So that the whatever the information I shared with you, it's all for the solid slab, not for the hollow core slab. uh, Yahya, hi Yahya, you ask a question. In Fixperience software, for the design of plate thickness, we can take the stress effect on concrete divided by deflection value of concrete. What is the default value in software? Is this, for example, 0.5 mm or 1 mm settlement of concrete? Yahya, like for these questions, I don't have answer now. I will come back to you regarding these questions. I will check with my international German team, like what is the actual value and based on which method it works. Is there any settlement or not? I will come back to you surely, sir. Thank you very much for your question. David. Hi, David. You ask one questions. I can see what is the anchor in relation to the weight? How do we come up with the size of bolt size in relation to loading? Wow. David, this is very simple design actually. You can do this design in maybe 5 minutes, 10 minutes if you install Fixperience. Just install Fixperience. If you need any support, send us mail. We will be in touch with you personally and we will explain like how we can do it. It's very easy. Just make the base plate on the design calculation and put the load directly. So you don't have to bother about which kind of anchor will work, because there is one tab in software, it's called multiple design. It will tell you which all anchors are passing for that particular load. I mean, you can choose from there the economical one, so you don't have to bother about you are going for higher dia or lower dia. You can easily see which the lesser dia is passing with that particular load. It might be chemical anchor or it might be mechanical anchor, but it is very feasible. Install it and then we can discuss again regarding it. Thank you, David. Siegfried, you ask a question. Will you provide the Fixperience software? Yes, we are providing. It's free of cost. You can go to the website and download it. We will give you the link in our chat button, or we will come back in touch with you to give you the software. It's very I mean, it's free of cost. You don't have to do anything. You just need to register your mail ID with your name to get the activation code. It's free from side of Fisher. Yeah, thanks for your answer. You are welcome, most welcome. Yeah, I mean the bearing capacity of slab, concrete, stress or deflection. I asked about deflection value default in the software. Thank you. Yes, I understood. You are talking about, are we checking the slab concrete stress or deflection? Yes or no? If I'm wrong, just let me know. You are asking the question like, is concrete slab or concrete slab stress or deflection is taking consideration in our anchor design or no? Okay, yeah. Okay, I will come back to you regarding it to give you the correct answer for it. I will come back to you. So, ladies and gentlemen, I want to thank you again to you for your time and for your polls, your opinion, your feedback. We value it, and we will try to overcome all the cons whatever we have, and we will try to make your next webinar much more good. So I will also ask you to send email to if you are having any questions, send mail to enquiries, ENQUIRIES, enquiries @fischer, FISCHER, fischer .ae. You can send your inquiries to enquiries, ENQUIRIES @fischer, FISCHER.ae, your inquiry, and your inquiry will be answered. Giridharan, you ask another one questions. I will take these questions as the last question, and we will come back. We will be in touch 100%. Can we use calculated base plate thickness in Cfix? What if we get less thickness by FEA analysis? Is it mandatory to provide the thickness given by Cfix? Giridharan, 100% no, sir. This is which you are getting the plate thickness in Cfix. It's basically a extra support or extra services towards you for a small design if you are doing the design calculation for anchor. So basically it's also doing the finite element analysis in Fisher software and giving you the thickness of the plate, but it's much more good if you are doing this one analysis in your finite element analysis software itself. This is just an add-on on our software do the base plate thickness check. Most of the time you will get almost the same thickness which you are getting in finite element analysis from finite element analysis software, as I believe the base plate thickness calculation is time consuming, and which can save your time by just doing the calculation in Fisher experience. So I will recommend you to use that. If you are using finite element analysis, it's much more better. You can go for it. I will never stop you personally. So thank you very much for your active participation. I appreciate Giridharan, Yahya, and all of you for your questions. I hope you got proper answer. I will come back regarding the and questions which I did not able to answer now, and be in touch with us. Let's grow together, learn together, and looking forward. Thank you very much. Thank you very much to all of you for your time.